In March, scientists in Switzerland announced that they are confident their experiments with the world's most powerful particle accelerator have finally turned up the long-sought Higgs boson. The discovery of the Higgs, often called the God particle, may provide clues to some of the most profound mysteries of the universe.
The search for the Higgs began decades ago at the Fermi National Accelerator Laboratory near Chicago, Illinois. VOA's Kane Farabaugh has done a lot of reporting on Fermilab, and Alex talked with Kane about the latest on the Higgs boson. Let's take a look.
Kane, when we spoke last July about the Higgs boson, scientists were saying that they had discovered a Higgs-like particle, but they were stopping short of actually saying it was the Higgs boson. So what's changed since then?
Well, they're almost saying that it is the Higgs boson. Some 200 scientists and other staffers gathered at Fermilab at 2 o'clock in the morning to watch the announcement from Geneva. Many of them have strong connections to the CERN experiment, using the atom-smashing Large Hadron Collider, or LHC, to locate the Higgs boson. Scientists have spent hundreds of millions of dollars and tens of thousands of hours of manpower poring over the resulting data.
So what will be the practical applications of this? It's all very complicated.
This is going to help scientists understand why and how we all exist here. Fermilab staff scientist Robert Roser says the Higgs boson is a particle that attracts other particles and explains how matter has mass. This gives clues to how planets and ultimately life is formed. But he points out his colleagues at CERN were careful to say they found a Higgs-like object, but not the Higgs boson itself.
It's a subtle difference, and so what they will do over the course of the next many years is to start to investigate all of its properties to see if it acts, if it smells, tastes, and behaves the way they expect it to.
So what's the future for Fermilab, Kane, and what are their future projects that they're working on now?
Technical Division scientist Andy Hawker is working with physicists at Fermilab to build the next generation particle accelerator, one that will someday make the LHC obsolete.
You know, what we're basically planning to build here at Fermilab is basically the most powerful, not the highest energy, but one of the most powerful proton accelerators in the world.
Instead of particles being accelerated around a vast circle, as with the LHC, Fermilab's new linear device, housed in a facility about 31 kilometers long, would aim two particle beams in a straight line at each other, much like two bullets fired to collide with each other at the speed of light.
The advantage of a linear accelerator is that you don't have to, for example, keep those particles on a stable orbit. You can just, it's much easier, you can imagine, it's much easier to send something in a straight line than it is to keep it in an orbit in a circle.
While the technology for the new International Linear Collider might be developed at Fermilab in the United States, engineering physicist Elvin Harms says if it is approved, it might not be built there.
Right now, I'd say the odds on the Japanese are showing the strongest interest in hosting the International Linear Collider. But I would say that the term, the first word international is important because this is necessarily going to be an international collaboration.
The International Linear Collider project includes about 2,000 people from 300 universities and laboratories from 24 different countries. The estimated price tag, between $7 and $8 billion.
You had a chance to actually go to this center where they're doing the research, to Fermilab in the U.S. state of Illinois. What was that like? I mean, what is it like when you go inside? What was the energy like, the buzz around? What was that experience for you?
It's a buzz of activity. These scientists are there poring over these computers, looking at all of this data, and it's, to the average person, it seems to me that if I was a scientist, I would be highly energized and very excited by all the stuff that I saw that's going on there. As a reporter who, again, not being a physicist, I only have, somewhat of a partial grasp of all of the stuff that they're trying to find out there. But even I'm a little bit surprised and I guess overwhelmed or even energized by being in the same room with these guys who seem to be excited by what they're seeing.
And that was our VOA Midwest correspondent Kane Farabaugh. Thanks to Kane for that update on the Higgs boson.